All right, let's jump right in. For today's deep dive, we're looking at something that's pretty much invisible to most of us, but absolutely critical. We're talking about the fiber optic coupler, or splitter, I should say. We're focusing on this one device, the Thor broadcast F-PLC-1x32, to really understand how our modern networks manage and distribute signals.
And it's a fascinating piece of tech. Its job sounds simple on the surface, but it's actually incredibly demanding. It has to take one single high-speed optical input, just one, and split its power reliably across 32 separate outputs.
32, that's a huge ratio.
It is. And the specifications, they really tell the engineering story here. They guarantee something called an insertion loss of 4 dB.
Wait, hold on. 40B, to me that sounds like a big drop in signal. Is that actually good?
It is a drop, you're right, but it's all about the context of that split. 4 decibels of loss means that roughly 60% of the original light signal is still getting through. And to take that much signal and distribute it reliably to 32 separate users, well, that's the whole point.
Ah, okay, so it's a necessary trade-off for the distribution.
Exactly. And that's before you even get to things like low polarization dependent loss, or PDL, which is just a fancy way of saying the material won't accidentally filter out light waves based on their orientation. You need all of it for a clean, consistent signal.
You know, what's really striking me here is the ruggedness. I mean, it's a standard 1U rack-mountable box, but the temperature specs are just extreme. It operates from -40 Celsius all the way up to +85. That's not meant for a cozy, climate-controlled data center, is it?
Absolutely not. And that right there tells you where this component lives. It's designed for the edge. Think about a remote cell tower, or maybe a street cabinet that has no heating or cooling system whatsoever.
So this is the backbone for things like fiber to the home, FTTX, and all that?
That's it exactly. FTTX, FTTH, and especially what we call passive optical networks, PON and GPONs.
Okay, so just to clarify for everyone listening, what defines a passive optical network?
Passive means the splitter itself. This FPLC 1x32 requires no electrical power, no cooling. It just sits there and works. That's why that extreme temperature rating is so critical. It has to function perfectly, completely unattended, whether it's in a Canadian winter or an Arizona summer.
Wow. So this one nearly $1,000 device is just this ultra-durable hub for everything from LANs to cable TV.
It is. And since that fiber has to connect somewhere, that brings us to the final piece of the puzzle, the connectors themselves.
Right. The source material mentions 4 main types for single fibers, LC, SC, ST, and FC, which I have to ask, if the goal is efficiency, why on earth are there 4 different plugs still being used? Isn't that a nightmare?
It's a great question. It really boils down to specialization and, frankly, legacy designs. Different needs drove different plugs. So you take the LC connector. It's tiny. Its ceramic ferrule is only 1.25 millimeters, which is half the size of the others.
So that one's purely about density.
Exactly. Jamming as many connections as you can into a high-density switch. It just snaps right in.
Okay, so that's LC. What about the SC connector?
SE is probably the most common balance. It uses the larger 2.5 millimeter ferrule, but it also has a quick snap-in mechanism. You see it everywhere in corporate environments for fast patching.
And then there's the ST, which sounds different.
It's very different. It also has a 2.5 millimeter ferrule, but it uses a bayonet twist lock, kind of like an old camera lens.
Oh, interesting. So that's for security, to stop it from getting pulled out by
You
accident,
got it. Think high vibration industrial settings. That's where you'd want an ST.
which I imagine you trade for installation speed. And the last one, FC.
FC is a screw-type connector. Very secure, but it's becoming less popular. In modern data centers, the speed and density of LC and SC are just winning out.
So what this all really means for you, the listener, is that we've looked at this single, extremely durable component, and it turns out it's the resilient backbone protecting your high-speed internet, distributing data to dozens of places while withstanding incredible environmental stress.
And that raises a final interesting question for you to mull over. Given this massive global shift toward high-density fiber installations like FTTX, think about the physical challenges of maintaining compatibility when you have 4 different connector types still in common use, from the tiny new LC snap-in to the large legacy FC screw type. What happens when the demands for speed and size finally force the industry to standardize?